good evening, depends on when are you watching this video. I'm going to explain on this video Unit 4, Part 1, which I divided in 3 parts. On Part 1, we're going to learn how to calculate the variance and the standard deviation. What does that mean? As we took before, we know that we can analyze the data graphically, what we took in Unit 1, all the graph, as well in Unit 4 for the whisker and the box plot. And we also learn in Unit 2 how to analyze the data numerically by learning the measurement of central tendency in Unit 2, as well the range as a measurement of the dispersion or spread. And today we're going to learn how to calculate the variance and the standard deviation, which is part of the measurement of dispersion or the spread. The main difference between the range and the variance and the standard deviations, the range is giving me how spread is the data altogether, but for the variance and the standard deviation is going to tell me how spread is each data from the mean, which is very important as the main difference between the range and the standard deviation. A quick understanding about the relation between the variance and the standard deviation, that the standard deviation is as simple as the square root of the variance. So if I give you the variance and I'm asking you to find the standard deviation, it's simple as you're going to go to the calculator and you're going to put the number under the square root. Again, a quick understanding, what do you mean by the standard deviation? What is the number mean? If the number is small, what does it mean? If the number is large, what does it mean? If the number is small of the standard deviation, that means that the distance of each data is very close to the mean. And that's what expecting to have a small standard deviation. A large standard deviation, that means that the distance of each data is far away from the mean. Another way to think about this one, to looking at these pictures, as you can see in these pictures, we can see all the data, which is all the men, our data, are very close to the mean, which means I'm expecting a small standard deviation. In the other pictures, I can see all the data, which also are all the men, are far away from the mean, which I'm expecting a large standard deviation. Let's go now and understand or learn how to calculate the variance. As much as I know how to calculate the variance, as easy as I will calculate the standard deviation by doing the square root of the variance. So let's learn first how to find the variance. I'm going to explain. Stop me at any time to try to do it on yourself. Stop the video at any time and pause. So we have here 5 data. We're going to learn here only 2 steps. There are a total of 3 steps to find the variance. The first step is we have to find the mean. Why we have to find the mean? To be able to find how far is each data from the mean. And that's the first step, and we learned that in Unit 2, which is adding all the data and divide by how many. And then we're going to create this table with 3 columns. The first columns we're going to write all the data, which is given. And then in the second columns, we're going to take each data from here, 1, and we're going to subtract from it the mean that we calculated in step number 1. On the last columns, we're going to take these numbers and square it, put to the power of 2 on my calculator. Stop me at any time, pause the video so you can try all by yourself before you see the answer. We're going to see here right away that we found that the mean is 3, which is I add all the data, divide by how many. And then I filled out all these tables by putting the data first, by subtracting the mean, which is 3, from each data. So I wrote 1 minus 3, and I found it's negative 2, and so on. And to make sure that you are right, you have to, when you add all these columns, it must be always, it doesn't matter what kind of data you have, it must be always 0. And you also notice that this columns has all kind of number, can have negative number, can have positive number, can have 0. What is negative number mean? Mean that the data are below the mean. Positive number mean that the data are above the mean. 0 mean the data is exactly the same number as the mean. And then we go to the last columns, which we take these numbers and we square it. We put it to the power of 2. And these columns will always be positive number. So if you have a mistake and you found it's minus 4, just ignore it. One of the easy way to do it, ignore the minus from here and write on your calculator 2 square, you will find the 4 right away. And then we're going to go to the last step, which we did not say it yet, is we're going to add all these numbers and we're going to find the sum. That's all I want from this table. We'll come to the last step to find the variance. To find the variance, again, the variance has a symbol of S square if it's coming from a sample, or sigma square if it's coming from a population. How do you find S square or the variance? We take this number 10 and we divide by n minus 1. What's my n? Is the number of the data. And I do have 5 data here, so it will be 5 minus 1, which is 4. So this will give me right away the variance. And as we said before, the standard deviation is as simple as the square root of this number. We're going to go to another examples. Again, stop me at any time so you can try it all by yourself. So again, the questions is find the variance and the standard deviation. So you're going to go through all your 3 steps again. I'll show it to you here again how you find it. The first step is to find the mean by adding all the number divided by how many. We found the mean is 6. We create our table and we fill out all the tables, the numbers. And as we said, we found that the sum here is always equal 0. As we can see, we can have positive number, negative number, or 0. But the last columns must be all positive. We found the sum of these numbers. What do you mean by the sum? The total, which means I'm adding all these numbers together to get these numbers. We go to the last step, which is only take these numbers and divide by n minus 1 or divide by n if it's coming from a population, which is 10. We found the standard deviation by doing the square root of this number. So we did a nice 2 examples. We have also another example here for you to do it by yourself. Again, pause me and try all by yourself. And here's the answer. We found that the mean was 8, and that's why we subtract here the 8 from all the data. And we found here the sum is 10, which is this number. I'll take this number divided by n minus 1 to find the variance, which is 25. The square root of 25 is 5, which is my standard deviation. We're almost coming at the end of the lesson, but try to understand a little bit what are the number that we are finding, which is the standard deviation. So if you have 2 sets here and you go through the same step, I'm giving you the mean is 6. So if you add and divide by 3, you will find 6. And also the standard deviation is 1 for the data A. For data B, we found that the mean is 10 and the standard deviation is 1. If we look at this data, we're going to find out that if I want to draw it as a symmetry, as we took before, because the mean is the same as the median, so they are definitely a symmetry distribution. So when we draw them, we draw the set A away from set B because the mean are far away from each other, but they have the same standard deviation. What does that mean again? Mean that the width of my shape is the same. I put for you here actually a link. If you click on this link, you will see how can you play with the mean or the standard deviation, which I'll show it to you right now. So I go to this link that I showed to you before, that I put it on the link. And as much as I change the mean, as we can see, if I change the mean, you can see that the shape is moving either to the right or to the left, but the shape is the same. If I try to change the standard deviation, how it will show in the graph, it will show by going either wider, so that means that I have a standard deviation large because the width of the bell shape is getting far away from the mean, or if I make it smaller, you can see that the peak is going all very skinnier because all the data are very close to the mean. So that's a nice way to see that. Same thing in my next one, which is how can we see now from this graph, we can see we have 3 sets of data, and we can actually comment on that by saying definitely that the green curve, which is data C, is more spread because we can see that the standard deviation, definitely I'm expecting here the standard deviation to be larger than set B and to be larger than set A. If I'm looking at which set now had the smaller standard deviation, I can see it's the set A because it is the skinnier. As it goes, the data are closer to the mean from any other one. which is another kind of example. They give you in a table instead of graph, they give you all the mean is the same and the standard deviation are different, and they are asking you which one is the least spread and which one is the most spread. Again, we learned that the most spread means that the larger standard deviation we have, which we can see that it's data set B is the larger one. And we can see right away that the least spread one is which data? I can hear you saying, which is expecting to be the smallest standard deviation, which is data. Excellent job. I can hear all of you saying data C. Awesome. I will leave you now by practicing more. If you need any help, you know where to email me. So you need to practice on the booklet as well, the review exercise on this exercise. Good luck.